All right, let's try that again. We're going to go through how to find the equation for each of these functions. I don't know. And as we go through these functions, the big thing will be tips and tricks and pieces on how to put them together. I'll start with doing the amplitude, then doing the period, then doing the midline for each of these equations. The trickiest part about some of these is that first step. Yes, sir. On my desk. Wait, it's just the micro USB. They're in a bag over there. Look in the yonder pouch next door. Okay, so let's do amplitude. Now, I remind you, the amplitude is defined as the distance from the midline to the top and from the midline to the bottom. So, there is a formula for this. I am not a huge fan of the formula because, well, there's enough formulas already in this section. However, looking at 24, the formula that you could use, it says take the max plus the min and divide it by 2. Wait. There's 2 different versions of this one. There's one that's plus, one that's minus. I have to do it right. That would work. Right. I think it's the minus. Like I said, this is why I don't like the formulas for this section because there's so many of them. So, in this case, 2 and 4, so I add those together, I would get -2. And divide that by 2, I would get -1. Yeah, that's the midline. Okay, so the minus should tell me my amplitude. Midline? Madeline? I think it should be plus.
I think you're backwards.
I don't know.
Was I backwards?
It's minus is the absolute value on top.
Like that? This is why I hate the formulas. I'll be honest, when I look at these ones, I don't use this at all. Ever. I eyeball it. I eyeball where the midline is. I say, okay, here's the top and bottom, there's the center, -1, that's not so bad. And I just count how far it is up and how far it is down from the midline. I rarely go in this order. I will do the midline first every time because it's an easier one for me to visually see. And I just count up and count down to make sure my amplitude is correct. And I know it's correct if I count up the same number as I count down. For example, in this picture, I'll zoom in a little bit. Come on, baby. There we go. Yeah. So I can see mine. Come on. Ugh. Okay. Let's do it again. Oh my god. I hate you so much. Okay. So, I can see here, I think, based upon visually, the midline is going to be here at -1. And I verify that by checking and seeing if it's the same distance up as it is down. So from -1, it is 1, 2, 3 up, and 1, 2, 3 down to get to my minimum. So I would assume that for this function, my amplitude is 3, my midline is at -1. Now, the period is how long it takes for it to repeat itself, to go from start to finish one time. Now I can see right here, if it's cosine, cosine starts at the top. So look right here. The top is right here at 0. The next peak, the next top is down there at pi. This would tell me for this function, the period would be pi. Again, for this function, the period would have to be a pi value. Because again, it's the distance it takes to travel from top to top, or from bottom to bottom. It's just the distance. So, try this again. I can do it. Okay. So I've got my amplitude, I've got my midline, I've got my period. This is most of the pieces we need to solve this problem. I don't think for any of the ones in homework there was any phase shift. But please correct me if that is wrong. Nope, no phase shift. No phase shift. Yep, no phase shift. Beautiful. So, we've got the 3 that are pretty easy to do. And then from there, we had formulas to determine each one of these. The amplitude, we said was equal to the absolute value of A. So this tells you that my A is either 3 or negative 3. So when I go to my equation, y is equal to A cosine of bx minus c plus d. I'm using the cosine formula because it says in the problem this is a cosine function. Well, what do I know? Well, my A value has to be a 3 because that's related to my amplitude. My D value has to be a negative 1 because that's related to my midline. The trickiest part here is how the period fits together. But remember, the period is assumed to be 2 pi over b. So if I know my value for the period is pi, that means my b has to be a 2. And since there's no phase shift, there's either a 0 there or nothing there at all. 27 does? Let me take a look.
It's right next to 20.
Okay. Ooh, it does. Ooh. Okay.
Sine has cosine.
It is cosine 1. If it had been a sine 1, even if it was a sine 1, it still would be off. Okay. Let's do 27 together then. Alright? Let's do 27 as an example together. Okay, so notice the process that I went through in the previous one. I looked at those 3 pieces. I can do them in pretty much any order, so I look at the ones that are easiest to see first. Okay, if the midline's easy, I grab that first. If the min and max are easy, I grab those next. If the period's easy, I do that last. Well, let's try it again. Take those pieces out. I'm going to add in my last line as phase shift. Okay, here we go. My reminder, phase shift is defined as C over B. So if I can turn my phase shift, it's going to be really helpful here to do it one piece at a time. So my amplitude, as a reminder, this is my A value. My midline, this is my D value. My period, 2 pi over B. My phase shift, C over B. Now you'll notice that when we go in this order, the first 2 are the easiest to solve for. These last 2 are harder to solve for. And if you solve for the period first, finding the phase shift actually gets easier. Okay, let's go in order. Amplitude first. In this picture, my amplitude, remember, is a distance from the midline up and the midline down. In this problem, what's the amplitude? 4. So it tells me my A value is 4. My midline. The x-axis. So that would mean that my D value is a 0. It's the x-axis. Remember, there's 2 different ways to think about it. There's the 0, which is the value. There's where it's at, which is the x-axis. Okay, the period. The period is the distance from either top to top, bottom to bottom, or the same value to the same value. So in looking at this problem, just to let you know as a perspective, I could determine the period by going from here to there. That's a period. So it's one full cycle. I could also determine it by going from here to there. That is one full cycle. They're the same thing.
So the same value is -2 plus pi over 2?
Yeah, which is a weird number, right? I probably don't want to go with this number to this number.
Well, you have to.
Do I have to? Yeah, in this case. So let's try it without it. So in this case, my left-hand value, as a reminder, to find the period, it is start and finish. Let's see, I think I actually had a formula written down for it. The period. Oh, other way. Yep, it's the other way. So it is the end value minus the beginning value. This will always determine your period. This is a nice little formula to have. So let me plug in that formula. Where is my end value? So you'll notice that he has to choose this spot and that spot to determine the period, because those are ones that are known, right? I can't choose this one because what's the x value? I don't know. So I'm going to put a little addendum here. It's the beginning and end x values. I'm choosing the x values to determine my period. The period is determined by the x's. So my end is at pi over 2 minus my beginning is at negative 2 plus pi over 2. So my end, pi over 2, my beginning, negative 2 plus pi over 2. So I take end minus beginning. Notice I put it in parentheses because I want to subtract the entire beginning piece, not just one of the pieces. So again, the end value minus the beginning value. Let's see what happens. I take pi over 2 minus negative 2 plus pi over 2. I distribute the negative sign, so I end up with pi over 2 plus 2 minus pi over 2. Distribute the negative to both terms. The positive pi over 2 and the negative pi over 2 would end up canceling, meaning I end up with a period of just 2. Now, what's important to remember here, my period is 2, but my period is also equal to this equation. Those two things are true at the same time. My period is 2. It takes 2 units of measurement to get from the beginning to the end. But my period is also equal to 2 pi over b.
So B would be pi.
So b ends up being pi. I can solve that by taking 2 pi over b equal to 2, and then just try to solve for b. I can do that by cross multiplying, or I multiply both sides by b. I end up with 2 pi equals 2b, or not 2b. No? Shakespeare? All right. Divide both sides by 2, I end up with b is equal to pi, which is really helpful if I want to write the equation because that gives my b value. This is a common approach with these kinds of problems, is that we already have equations involving these variables, but in the picture we can find them manually. So what I do is I connect together the formula from the picture and the formula from the problem, and then solve backwards to find what's actually in the equation. It's a weird process, and it takes a little bit of practice and getting used to, but it works very well. So let's see now. We now know the a value is 4, the d value is 0, the b value is pi. All that's left to find is the c value, the phase shift. Now, I have a formula for the phase shift. It's right there. So I need to figure out how long does it take for me to shift from where I should have started. Now, there's actually a couple ways to do this. I'm going to go actually to over here. I see that the top of my function is right there lined up with negative pi over 2. So what I'm going to do is I'm going to use that fact to determine what the phase shift is. There are multiple correct solutions. I told you that before in class. There are multiple correct solutions. This will give me one of them, and I think it's the best one to find. Here's what we're going to do. Come on, work. Yes. You're just patient. Okay. I know for my problem, my phase shift is at pi over 2, or in this case, negative pi over 2. So my phase shift is negative pi over 2. But I also know that according to my phase shift is equal to c over b. So negative pi over 2 is equal to c over b. So I know something from the picture, and I know something from the formula I'm going to have to solve. I already know what a is, I already know what d is, I already know what b is. So now what I do? This b is pi. I work backwards, trying to solve for what c is. Let's do it. I take this picture, I cross multiply, I get negative pi times pi equals 2 times c. Cross multiply. Divide both sides by 2. I get c equals negative pi times pi. Negative pi times pi is pi squared, just like anything else. If you times it by itself, it becomes squared. And so my C is negative pi squared over 2. Pretty neat. Okay. I have A, B, C, and D. Let's look into our equation. Our equation is y is equal to A. My A value? 4. I chose a specific phase shift to avoid that. What she's talking about is down here, there is a negative version, which you could use instead, where you assume that this is a starting value, which notice is flipped. You could use that one, and it would work. You get a slightly different version of the answer, but I'll bet that if we graph your answer and we graph my answer, they should be the same thing. Because that's the point, is that if I choose a different starting place, as long as it's still a cosine function and I follow all the cosine function rules, it should be the exact same solution, even though it may look a little different along the way. So for mine, I'm assuming this is the starting place. So if I do that, then my amplitude would be a positive 4 versus down here would be a negative 4. And then come in, cosine. Okay. Next would go bx. So b is pi. So pi x minus c. So we do minus. My c value is right here. The c value is negative, so it would be plus pi squared over 2. Plus d. D value is 0. There's our solution. Now, I chose, it's important to note here, I chose this phase shift. Madeline, you said you did this problem already. You chose this phase shift. Was it easier to find C? No. So in this case, the C is just nasty. Okay? It just is. So in case you wanted to know, I could choose any of these to be where my starting phase shift is. I could start here. I could start there. I could start here, but that's actually the single worst solution you can make. Because if I start there, where's the x value? Don't know. I could also, in theory, start down there as well. I think it works. It's a little different. No matter what, though, I think this is going to be some weird numbers for our C value. Now, this may mean that for your problem, you may get a slightly different version of the solution than what the book has. If your solution is different from the book solution, don't freak out. Test it. Graph their solution, graph your solution, use Desmos, use some graphing function, see if they match. Because if they still match, you're still right. That is key. If they still match, you are still right.
I'm pretty sure they have a high factor out of their
Probably. Probably.
equation.
I'll give you a guess. Their version, if I had to take a shot in the dark, was probably cosine of pi x plus pi over 2 with a 4 out front. Yeah. They'll do it. Like, in theory, it should be the exact same thing.
How do you just take the square away?
Well, because when we factor the pi out, we take a pi out of both pieces.
Oh.
We take a pi out of the pi x, which means it's just x. We take a pi out of pi squared, leaving one of the pi's behind. You see that at negative 4? So in theory, these two should be the same. It's a slightly different version of them. Okay. That's fun.
You do 15.
I didn't remember 27 being so tough when I did it. That was a fun one. Okay. Let's take a second and reset. I'll take a look at 15 in just a moment, but
I've noticed some differences.
what's the differences?
I typed them both into Desmos.
Okay. Let's take a look, shall we?
So,
Do you have this one, and do you have both of them on your calculator so I can see?
oh, I'm just checking to make sure I have them right.
Alright, let's pull up. Desmos, come here.
Maybe the books or something else.
I mean, it's possible. I'm going to reference the book to see, like, the problem itself, to see if it matches. That's how I'll know if it's right. Okay, ready? So, the equation I got was 4 cosine of pi x plus pi squared over 2. That's the version I got, right? Well, let's look at some things here. It looks like mine is upside down. That's the first thing I noticed. It looks like mine is upside down, which would lead you to believe that I must have missed a negative somehow. That's why it's really important to check with a lot of these. Please check.
I knew it. I knew something was off.
Okay. Well, now we found it, okay? Now let's check and see if the other values are still correct, okay? So right here, that should line up with negative pi over 4.
It works. It lines up.
It lines up.
Yeah, like it.
Over
Put that
there.
negative there. Everything's fixed.
Okay, wow. How nice. Okay. As you can see, this is not a perfect process. Like, we try our best to figure it out. But again, along the way, check your stuff. The goal is you have the tools available to you. You're trying to make the best approximation as you can based upon what you visually see. You have the tools to check your work. Check your work. Like, I noticed I'm looking at it right away, and I'm like, this doesn't look right. So what could be wrong? Well, one thing was off. All the hard stuff was actually fine. It was a negative sign.
So we get decimals on our test.
Your ones in your test will not be this complicated.
Thank God.
Never, 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 never. Dear Lord, that would be cruel and unusual punishment right there. No, the ones in your test will be more like what we see on 24. Like the one before.
Wow. Surely
Now that right there, that would be like, if you make me extremely angry before the test, I might throw you a 27 up there on your test. But otherwise, you're going to be looking at ones like 25, you know? Much simpler to follow through on.
So basically, ones without patience.
True.
Where are you going?
Okay.
Like, go back to the school.
We asked some questions about ones like 15 and questions like ones like 30 and around those numbers. Let me pull those up real quick. 31.
And on. 31 and then all the way. Yeah.
Okay. All right. Let's take a second. You may want to take out some notes for this because these are actually all algebra questions. London, focus. Come on. These are all algebra-based questions. Levi, you too. They're actually asking you to solve this with the algebra mindset. So let's remind ourselves what some of these terminologies mean. 31 asks, for the following exercises, let f of x is equal to sine of x. What does that mean? 31. On this interval specifically, because remember, there's actually as many intervals as you want in this function, because remember, it repeats itself. Solve for f of x is equal to 0. But think algebraically. What does it mean when a function is equal to 0? The y value is 0. What does it mean when the y value is 0? We have a fancy word for this.
X-intercept.
X-intercepts. So 31 asks it in a kind of a weird way, but it's actually the algebra way to ask the question. It says, hey, when will f of x equal 0? But it's asking you for, hey, in this interval, where are the x-intercepts? As it turns out, if I graph this function, x-intercepts are pretty easy to see. I would, yeah. Next one. This is actually from last chapter. It says evaluate f of pi over 2. Well, what that means is, remember, this means plug in. Pi over 2. What happens if I plug sine with pi over 2? It's 1. You can do that in the unit circle. Okay, but these are algebra questions. They're not trig questions. Because we're asking you to evaluate a function. This one just means find x-intercepts. This one here means to plug in that value. I would type in sine of x. Are you referring to this one? 31? So, to do number 31, So, 31. You can solve it one of two ways. You can graph the function and look for the x-intercepts. There's two of them. And you could also, instead of doing that, you could use the unit circle. Because what it's asking you is, when is that value equal to 0? When is sine equal to 0? So in other words, on the unit circle, that's specifically when the y values are 0. And that happens twice. See it up here? Function sine of x. Now remember, it has to be between 0 and 2 pi. So that means I'm going to start right there, and I end just before I hit 2 pi. So that's what the symbol is, right? The parentheses means just before. So where are my x-intercepts? Well, one's there at 0. The other happens right here at pi. So these two are my two solutions, because they're the x-intercepts for the sine function. Yes, these are algebra questions. They're fun. Because we haven't talked a lot about the algebra side of the trig. And again, I don't use a calculator for either of these. I use the unit circle. That's why we spend so much time talking about the unit circle. Because you can use the unit circle to solve every one of these. If the question asks, hey, when does f of x equal 0? That means, when does the sine function equal 0? Well, that's on the unit circle. What I find kind of interesting and frustrating about trig is how those two have to constantly be true at the same time. You have to hold the ideas of the unit circle in one part of your brain, and then you have these graphs and these functions in a different part of your brain, and they have to communicate. But they're always linked. You can use the unit circle to solve graphing things. You can use the graph to solve unit circle things. They're connected to each other, but our brain wants to separate them all the time. And so we'll look at a problem like we have on 31, and we could solve it either way. We could solve 31 just using the unit circle. We could solve it by just graphing if we understand what it's asking in terms of the graph, if we understand what it's asking in terms of the circle. We just have to understand those pieces. Now, going farther down, these ones are also algebra questions. 35. What is the maximum values of the function? When do they occur? At what x values? So again, it's asking you to look at the picture of that function and asking when is it at its maximum. You could also ask that about the unit circle. Look at the unit circle values and see which one's the largest unit circle value. That's a little tougher if you're not used to those weird fractions, but you can do it with just unit circle as well. Hey. Say one more time.
If we're going to graph it on decimals, the sine of maximum value, how do we plug it in? Because they don't give us an exact equation.
Yeah, they do.
Oh, so it's just that one?
Yep. It says for the following exercises.
Okay.
Yep. All right. Number 37. Show that f of negative x is equal to negative f of x. This is actually one you can do with Desmos as well. What we have to do is we have to graph two functions this time. One where the negative is inside of sine, one where the negative is outside of sine. And you'll see they are in fact the same. Here we go. The second piece is the definition we had as a test question last chapter. There was a reason it was a test question. It comes up again. Odd and even functions come up. So, odd functions are ones that are symmetry with respect to the origin. Okay, let's go ahead and show 37 using the calculator. Here's Desmos. Desmos says, okay, two different versions. One where the negative is inside, the negative inside. One where the negative is outside. If these two are the same, that means it is odd. Negative on the inside, negative on the outside. This one is f of negative x. This one is negative f of x.
Okay, so the odd ones where the negative doesn't matter.
Odd ones where the negative moves. Even ones where the negative doesn't matter. The negative disappears.
Okay, yeah. But that would make it different.
So, I used Desmos to do this one. great function tool to work, but I have to understand what it's asking me to do first. If I don't understand what f of negative x means, it means this version of the formula. And what negative f of x means, it means this version of the formula. Then it's hard to show those the same because I just don't have the understanding to do it. Again, the problem isn't hard, it's our understanding of the material to get it through. If I don't know those two pieces, how am I supposed to be able to do in our next step?
This is gonna be the longest, most stupid math section I've ever done in my life. Normally it's
You
like,
just wait.
maybe the first day is normal, the second day you get, this is like
What would
the
you use
second
this
week.
for?
Primarily, I used it mainly to do what's referred to as harmonic convergence. It's the idea that you take a function that cycles back and forth, and you use it to match to something that exists in reality. So we used it to actually make music when I was in school.
So if you're not gonna do anything with music, you're fine.
Well, so I told you at the beginning of the year, and I can't stress enough now. If you don't plan on going into a math and science field, then I'm sorry, you're not going to use this stuff. You're just not. There's no way to lie to you and make it sound pretty. I'm not going to. Okay? If you are taking this class just because you have to take this class, I'm sorry. I'm really sorry. Now, I've used it with harmonics. I've used it specifically when it comes to things like understanding wave formations. So we actually got to analyze some of the earthquake data after Fukushima. That was pretty cool. But the wave formations on those are based upon sinusoidal functions. So you understand how sinusoidal functions work, you can understand how those waves work and how they create such a big devastating wave. It's a weird thing. But again, I'm not going to lie to you and say, oh, you're going to use this every day when you guys know. You'll use it if you go into a field that uses it. If you're not going to go into one of those fields, you're going to take this test and be like, now I can forget it.
But I'm probably still gonna read it, to be honest with you.
Yeah, you get to.
Well,
You know.
you're going to get to relearn it.
So,
And that second time around, you'll be like, oh, yeah, I remember Douglas saying that. And you know what? I've had students come back and be like, yeah, I forgot it.
Just know that.
But then I took it again and I got it back. It's fine. All right. I'll continue going down that page for a little bit longer and I'll look at number 15.
What is it? It's the same thing.
there's architecture like hanging,
Yeah, I'm there, but
but that's possible.
it's basically the same. Are you?
He's giving me crap because I'm not going.
I wouldn't. I don't want to go at midnight.
Maybe.
I was gonna
I'll
go
be
first.
there Friday.
I was like, oh, that's fine, just watch it all.
I won't be there.
I guess it's not going to show up. Okay.
You never know. Never know.
I do know.
There's only like 8 people.
Last couple questions.
I'm even more like Miami. Maybe you can go to class.
Yep. Who beat him?
Okay. Last couple questions. I asked for something very similar but with the cosine function. Again, there's ways you can do it. Oh, there you go. There's ways you could do this specifically using Desmos. There's ways specifically you could do this without Desmos using the unit circle. But again, these are algebra style questions where they're saying, hey, solve when this equals 0. Well, that means we're looking for x-intercepts. 40 asks the exact same question just without using those words. Like, this is how algebra works. You can ask the same question in multiple ways, and they have different slight meanings. The same solutions exist, but they're there. This one asks to solve the equation of fx equal to square root 3 over 2. It's asking you, when does cosine equal square root 3 over 2? That happens twice on the unit circle. It also happens twice on the function.
Basically, you're using like cosine and sine as like your x and y.
Yeah.
Plans.
Yep. Same as we did with the unit circle.
So all these are just like Desmos.
Mm-hmm.
Sweet.
Now, these ones down here,
Take them.
these ask you to plug it into your calculator and solve. I think some of these are really neat. Like, graph this function and see what it looks like. See if you can predict what it's going to look like when you graph it. It's weird. Same with this one. Same with the bottom one. Like, they look weird. It's because they're defined in a weird way. So, graph those functions using Desmos and then answer the question honestly. Okay? Explain why it appears the way it does. Why do you think it's doing what it does? Alright, we also have about 15? Go back 15?
It's like the ones with the base shift, I didn't know worked like that.
Yeah, so 15 I did it, and then I was like, wait a minute. It's not cosine.
Was it just the phase shift? Just the phase shift?
Yeah.
So, with the parentheses in place, this does not match our normal definition for cosine. What I would do is I would get rid of those middle parentheses first. This would become 3. Oops.
You meant sine, right? Or else am I missing something?
15.
You said cosine.
I did? I'm sorry.
Okay, I was really confused. I was like,
Yeah.
Scott's and cosine. So I would get rid of this parentheses here in the middle where it says 8 times x plus 4. I would just take this as 8x plus 32.
Whoa.
The reason why?
oh yeah.
Remember, we're going to shoot the 8 to both pieces. This is now in our form of bx minus c. So what I can now do to get my phase shift is I plug in
Phase shift.
c over b. So that would be negative 32 over 8, which is my phase shift is negative 4.
What do you do on the graph?
I would go 4 units to the left and put my first point.
But you couldn't even gotten that with just the axis version?
Yes. This version is what we talked about in October, how you can have a function with something inside of it, making a change. That's what's happening here. This is an example of one where you can actually see that piece inside the function. This formula is if it's in that specific form. That's why we have that form to begin with. So yes, it does not mean that there isn't a faster way. I told you guys in class, like, these formulas work for this function, but there's always other ways. I'm just showing you guys what I think is the best one. Is the alternative to that, by the way? We're going to try to put all of them in this form, which takes
I already
work
did
as
number
well.
15, but I completely missed the inside parentheses, so I said 8x plus 4.
Ooh,
Can I just leave it? I mean, I did it.
I did it.
I could be wrong.
Come on, baby.
I'm sorry, man.
I still got 3 more I don't even know how to do. I gotta figure those ones out.
I'm sorry, man.
Come on.
We have about 10 minutes left.
Well, we got a break in here.
Yes, I have 5 minutes. Well, in this case, like let's do 15.
Like the whole problem?
Yeah, I'll do the whole problem. I got 10 minutes. Why not do it? We got 2 people asking questions. I might as well answer. 15. Ready? Okay, number 15. So my equation is, I'm going to use this version, which is 3 sine of 8x plus 32 plus 5. Okay. First things first, I put the midline, which is up here at 5. Beautiful. And then put the tops and bottoms, which are 3 up from 5. So 3 up would make this at 8. And at 2. Beautiful. So far, I've gotten rid of my midline, and I've done my amplitude. All right, phase shift. And period and x, right? So phase shift, we already said the phase shift is going to be negative 4. We use the formula to find the phase shift, right? So that means you need to go 4 units to the left. 1, 2, 3, 4. Now this is a sine function, right? Sine functions always begin on the midline on the phase shift. So if it's negative 4 units to the left, it would have to be right here is where it's going to start. At negative 4, up 5. Again, it's a sine function. It has to be on the phase shift on the midline. Cosine would be on the amplitude instead. Small change. So that dot's right. Next piece I would need would be to determine what the period is, where it's going to end. So for mine, my period is equal to 2 pi over b. So that'd be 2 pi over 8. 2 pi over 8 is just pi over 4. Okay, now this is not good. I have a negative 4 as my first point, and a pi over 4 is my period. I'm going to convert this into a decimal, and hopefully make this a little nicer. Not much, but a little. So what I do, I take this pi over 4, I plug in pi, which is 3.14, divided by 4, I get a value of 0.786. That goes money.
Oh my gosh. What?
You're off today a little bit.
I can't help it. It's Tuesday. Okay, meaning this function will repeat every 0.785. Oh boy.
That's so small.
That is so small, so tiny. So come over here. All right, green, where you at? There's green. Every 0.785 it will repeat. So that means the end point is actually right about, that hurts my soul.
It's like you were close.
I'm off today. What can I say?
What in the...
Okay, now this dot is at the value, so it is 0.785 to the right of negative 4, which would put it at negative 3.215, comma 5. That's the whole period. Meaning it will repeat one full cycle of sine in that period. Meaning it will reach the top and the bottom and one value in between in that cycle. Let's do it. So again, halfway in between. Oh my god, this is going to be terrible. Okay.
We'll just guesstimate and make our little, like, whoop-de-doo. Holy.
Halfway in between. Now sine starts by going up to the max, so I go halfway in between. And then hits the minimum. Halfway in between.
There you go.
One cycle.
15's 2.
What?
Oh, you have to do 2.
2 what?
2 periods.
Oh, 2 cycles?
Yeah.
He just measured it with his fingers.
Good job.
Can't check that. All right. I'm going to test a couple of really simple things. I want to test to make sure the beginning and the end are in the right spot. And if I know that's good, like the rest, I can eyeball and get really close. But I want to make sure those two are in the correct spot. So how I'm going to do that is I'm going to come over here. I'm going to graph my function, which is 3 sine of 8x plus 32. Yeah, that does some stuff.
Plus 5.
Plus 5?
Yeah.
Yeah, it
Looks about right.
well let's make sure everything looks about right. So it is definitely going between negative 2 and positive 8. So that much we got for sure, right? Okay. Now what I'm gonna do, in order to make this a little easier, because I know this value is based upon the midline, I'm gonna put the midline in here as well, which is when the y value is 5. What this does is this gives me some interactable points. So here we go. Down here at negative 4 should be the point negative 4, 5. That's in the right spot. One cycle later should be the point negative 3.215, 5. So one cycle is right there.
Oh.
What's that?
You have to put all the points in the middle of that.
What I would do, if I would have to do this by hand, I'm pulling out a calculator using formulas. Like, I am not trying to get this number just by looking at it. Calculator helps that.
Yeah, but
Okay.
I'm saying you get the right deal.
I would, yes. Say again? This one? So I have 1, 2, and 3. Oops, that's terrible. Okay, let me go in order. So 1, 2, 3, 4, 5.
Wait. Which one's the
Starting place,
uh,
ending place, and then the numbers in between. It's kind of ugly, but it's there. Yeah, you better believe I'm grabbing a calculator for this one. Like, I'm not gonna try to ever do this one by hand, like unless like I'm really feeling frisky that day. Like, it's just not gonna happen. Like, instead I should just be like, let me make sure for sure I have these pieces right, and then get the rest in terms of those components. Like, as long as I have the start and the finish right, I can estimate and eyeball where the middle of it's going to be. That's going to cross the midline because it's sine. I can then do the middle of each of those and do the min and max. And afterwards, I can use a calculator to find where they exactly are. But again, the rest of it is just eyeball. Which one? Sorry, I'm really deaf right now. Oh. The sine function?
Oh.
is anyone in here anatomy physiology? Any of you?
Why are you looking at my stuff?
Do you remember what's on the test? I need to know because I haven't studied.
Oh no.
For cosine, it's very similar, but instead of midline, it's amplitude. Works really well. That way.
You still my purple one? I did not. Erica.
What is that?
I'm here.
These are the formulas to find the beginning and the end, as opposed to finding it manually. I use the formula, that b plus a over 2. Yep, that's what I would do every time. It's the same formula for all of them, because remember, it's the middle of them, right? So b plus a over 2. So in this case, to find the first middle, I take the beginning plus the end and divide it by 2. That's only the middle. Do the same thing again with the next 2 points and the next 2 points until you have them all. It's a thing. I wouldn't mind. They're blocking off that way, Ebony. Sorry.
Yes.
Yes?
Yes.
Yes?
Uh-huh.
Did- Oh, no. How's it going, Trevor?